I'm back. Sorry, didn't realize I'd started recording. Okay, this is going to be, because here's the sheet we're talking about, the compound interest. Okay, it is on the back side of the assignment I gave you, Chapter 7-2, Solving Exponential Equations. Okay, what I have in my hands now is I have the answers to all the compound interest problems that you should have been able to solve or calculate. Okay, so here they are. All right, and again, you can just pause this and you can say, okay, Ms. Smith, I'm just going to pause it. I'm going to write. The last problem, remember, was a comparison of financial institution A with financial institution B. All right, and that was because you were going to say which bank produced the better deal based on compounded a certain n number of times a year or compounded continuously at different interest rates but having the same principal amount. So you're going to find out who did better. Obviously, financial institution B did, and by how much. So that's going to be a great life application problem, because you would not want to put your money in financial institution A if you were looking at the same time period and the same principal balance. And this guy's going to deliver, financial institution B is going to make you a much greater return on your investment. So that's, again, compound interest sheet from chapter 7-2. So practice this, okay, and go back and look at your problems, because a lot of you had said you struggled with this. Wait a minute, I have one more to do. I am so sorry. I promised you another one. So I'm going to do one like number 17, okay? This is a REX, right? A remote example. So I'm going to go to number 17 now. Same sheet. Okay, same sheet. Number 17. Okay, I'll read you number 17. Number 17. Rob in an account with a fixed annual interest rate of 4.63%. Okay, so here we got Rob. Okay, it is an interest rate that he is being paid, and it is R is for decimal form. That's going to be 0.0463. Okay, now what else does Rob have going on? The interest is compounded 12 times a year. N equals 12. Because that's what n is. Here, so we already know we're going to use the same formula that we did in number 13. All right, after 18 years, so he left it alone for 18 years, balance, or the account balance, reaches, so his ending balance is $9,428.70. What was the amount of the initial investment? The initial investment is P. Okay, that's what we're, all right, so we know it's compounded n times per year, so we already know the formula that we're going to use is going to what we just did in number 13. Okay, so let's put in, let me go ahead and write the formula. The account ending balance is equal to P times 1 plus the rate divided by the number of times per year that it's paid, and that's going to be raised to a power, which is the power is a product. Okay, so we are solving here for P. That's what we're solving for. Let's plug in everything else that we have, though. Okay, we have the account ending balance. That's given as $9,428.70. We don't know P. We know that 1 plus our rate, we know our rate, 0.0463. Okay, and we also know the number of times per year, so it's R divided by N. N is the number of times per year that is compounded. And this expression is going to be raised to a power that is the product of our N, which is 12, times our time, which is 18 years. Okay, so we have it set up, and it's as it should be. P is the only thing we don't know. Okay, so what we're going to do is we're going to say, okay, just like we did in the last problem, you're going to put all of this in your calculator and you're going to raise it to this power. So 9428.7 is equal to P. All of this is going to turn into this, and we want 4 decimal places, remember? All right, so I think I put 5 here for some reason, but that's okay. Okay, but 4 is usually adequate, but I went ahead and solved this out. All right, we're solving for P, so I have to divide both sides by what's in the way, and 2.29744 is in the way. Okay, so 2.29744. All right, you will put this in your calculator. Okay, you'll put that in your calculator. And then you're going to end up with P is equal to, if we raise it to the nearest dollar, 4,104. That's what Rob would have had to start his investment and let it grow at the interest rate and the number of years to reach this balance. So he can tell kids, okay, we need $9,500 by the time that you graduate high school, and the baby was just born. Then they know that he's going to have to go open an account with $4,104, and it's going to be compounded 12 times a year for 18 years at this interest rate. Okay, at this interest rate, and then he is going to have his target. Okay, he's going to meet his target, but he's got to start with. Okay, so hopefully that helped. I want you to work the rest of the problems out. I already gave you the answers to all of them, so go back and practice them because you will be glad that you did. All right, take care. Until next time, Miss Smith, St. Benedict at Auburndale, math classes. Thanks for watching.